So this is lesson 234, which is the last lesson in chapter 2. So we're going to go ahead and see what we can see. Let's get started. So in previous lessons, we have looked at many examples of the triangle similarity conditions. Today we're going to use some of these reasons to justify some of the similarity conditions. Then we're going to apply our understanding of similar triangles to prove other triangle relationships. As we work today, ask the following questions. What transformations can we use? Are any triangles similar? And what similarity condition can we use? Does AA similarity always work? Scott knows that if two angles in a triangle are congruent to two angles of another triangle, then the triangles will always be similar. But now his team has asked him to use transformations to explain why AA always works. Elena says, let's start with a diagram. I'm going to name my triangles PQR and TUV. I know that two pairs of angles are congruent. So I'm going to mark P congruent to T and Q congruent to U on the diagram. And Scott says, I think it will help if we can match up two of the congruent angles with a sequence of rigid motions that map angle P onto angle T. So how did we get from this image to that image? And so what did we do to this triangle to get it to look like that triangle so that P and T were in the same place? And so I'm going to go ahead and take my triangle and move it. I'm certain it had to be translated. I'm going to translate it onto T, and then I'm going to rotate it. I got my rotator tool, so I'm going to rotate it around point T. I want to rotate the right thing. Rotate it around point T. Well, it's not perfect because they were randomly drawn. I'd say that's what they did. So let's go ahead and write that down. Translate P onto T. I'm using point P onto point T. I'm going to neon translate. Rotate until sides are on top of each other. Now, the original triangles aren't drawn to scale. In the second one, we drew them the same because, again, these angles have to be the same. And so in the second one, we made sure. And in the first picture, they may not be drawn to scale. So just if you're wondering, well, that didn't really work, Mrs. Slopeless, that's probably why. And it could be my bad drawing. Let's be completely real. So what angle relationships in your diagram tell you about QR and UV? Q prime. So my new one, and it looks like I moved. I'm seeing QR is even bigger. See, not drawn to scale. Okay. So what is the relationship between this side and that side? So they've drawn that they're parallel. So they've drawn that for me, that they're parallel. That's why there's arrows here. And how do these two angles being congruent demonstrate that? Those two angles are corresponding angles. So since corresponding angles are congruent, those two lines have to be parallel because that's when that happens. Otherwise, they're not parallel. And so this is one of those statements that goes both ways. We didn't spend a lot of time talking about these. We actually skipped the section where they talk about, it's called converses. But this does go both ways. Not every mathematical statement goes both ways, but this one does. So if one is true, the other is implied. It goes both directions. So if I have parallel lines, I know the corresponding angles are congruent. If corresponding angles are congruent, the parallel lines are congruent. So this goes both directions. And you can't see what I'm doing with my hands, but I'm doing it anyway. All right. Elena says, hey, we can just dilate one triangle and then we'll have the other one. And Scott says, yeah, but we don't know the side length. So how do we dilate so the vertices match up? Help them write a scale factor that will take point Q onto point U if T is the center. So this has to be all letters. A number doesn't make sense here. We don't have any numbers. We don't This needs to be true for every single set of triangles in the world that have two congruent angles. And so we have to make this work with letters. And then that can be really, really frustrating, but this is a letter question. So our scale factor needs to help us do this. So we know that UT divided by Q prime T equals some number. Okay? So the length of UT divided by the length of QT equals some number. And we need to dilate them so that they're now equal. So that means we need to multiply QT by something so that I get UT. So if I multiply QT, Q prime T by some value, I need to get UT. What can go here? Let's check. So Q prime T times UT over Q prime T equals, the QT's cancel out, UT. See? So this is my scale factor. And it can be all letters. And the beauty of everything being all letters, and I know that this is really a frustrating thing for almost every student I've ever taught, is when it goes to all letters, they're like, not letters. Please, why are we using numbers? We're not using numbers, so it's true for every triangle in the world, for every set of triangles in the world, that all I'd have to do is this. And then I dilate by that scale factor. Whatever the relationship between the sides are, I need to dilate times so that they can be the same. Whichever one's going to become the other. So we're going to dilate back and make it smaller. So that's why UT's on top and QT's on bottom. If we were going to make the other way, it'd be QT. If we were going to make UT into QT, then we would flip it over. We'd use reciprocals. So that's really all there is to it. Okay? All right, let's see what we got. All right. Janelle and Cameron are working on their homework together. For the diagram at the right, Cameron wrote this equation. Is his equation correct? Explain. If needed, revise his equation. So he said 4 over 6. So 4 over 6 is equal to 5 over 5 plus 6. I think he's good. So we've got small on top on both and the big one on the bottom on both. It's just a little weird that one is that. I think he's good. The equation looks fine to me. So we don't need to revise it. We're going to just go ahead and solve it. I'm going to make 4, 6, 2/3 before I solve. I'm going to cross multiply. I'm going to work down here. I'm going to get 2 parentheses 5 plus x equals 15. I'm going to get 10 plus 2x equals 15. So 2x equals 5. And x equals 2.5. Okay. So Janelle wrote a different equation, but she still got the same answer. So is that okay? Is it going to always work that you can just do that? It seems strange because my problem with Janelle's equation is that 2 is not a whole side. So why is the piece proportional to the whole? That's my problem. Because you've got a piece of a small triangle proportional to a whole. But is she okay? She does get the same answer. We get 4x equals 10. And so x equals 10 over 4, which simplifies to 2.5. And just in case you missed it, this was 5 over 2 at one point, and then I simplified it to 2.5. And so there we are. So it's a pretty straightforward situation. What happens next is, so Janelle did part to whole. Okay, so let's go ahead and continue to our next slide. Oh wait, we didn't write that down. She did part to whole. So she did whole to the parts. I wonder if it always works. I mean, I never set it up this way because I'm very when I was young, I was very, very bad at these. And so I'm always really, really, really careful because I was so bad at setting up proportions when I was a child. And so I never, ever, ever would set it up that way. Ever. But that's how she did part to whole. And I don't know if it's true. I haven't done the research on that. Whole over part. So the whole side over the part of the side. Whereas Cameron did whole over whole. A whole piece over a whole piece. So we did small over big, the whole side. And Janelle only did part of the side. I think the reason it screws me up, because I think it does work on this, is it doesn't work when you use these two. And I think that's why I get all mixed up. All right, let's go. We have just some practice problems. Let's see if we can find the missing side. Yeah, just some practice. Good old-fashioned practice. How nice. I mean, sometimes it just seems like we do so much just grind and jump. So I'm going to go ahead and set up some others. These are set up the same exact way as the problem we just did. So 20 over 32. So part over whole equals 25 over 25 plus question mark. We're going to use X for question mark. And so let's see. I'm going to simplify this fraction first. 4 goes into both of them. 4 makes 5 over 8 equals 25. 25 over plus 25 over X. I times 5 by 5 to get this. So 40 is going to equal 25x. 25 plus X. So what I did there is I used some proportional reasoning. And I know the only way fractions are the same is the numerators are the same. So if this is 5 and that's 25, I need to times this by 5 to get this number. And so 8 times 5 is 40. And so I'm solving this. And X equals 15. Just to show you that it still works if I cross multiply. 5 parentheses 25. X equals 200. 25 times 8 is 200. So we get 125 plus 5x equals 200. 5x equals 75. And x equals 5. Go ahead and try that one on your own. Pause the video now and see what happens. So I first set up the part over whole, like the whole over the piece, just to see what would happen. And I did get 10, and then I did it the long way with cross multiplying, and I also got 10. So it worked again. And so then, just because I'm, nerdy like that, I decided to set up something here, just kind of see if it would always work. So A over A plus B, so like A over A plus B, which is equals C over C plus D, which is, if I cross multiply, and I need to play a little game here, which is weird. C plus D divided by C, A plus B divided by A, and I get 1 plus D over C equals 1 plus B over A, and the ones go away, and I can have part over whole. In case you were wondering. So you don't need to worry about that. That was just me proving something to myself. And that's not important. That's why I'm erasing it. You don't have to write that down. If you want to, I mean, whatever, but it's just me being nerdy. Okay. So let's try again. Let's see what's going on. Go ahead and try both of these. Okay. So on this one, I started with looking at, since that's 7, that makes this 3. And so I did 3 over 4 equals 7 over x. And so I know that that has to be 8 because I times by 2. You can do, again, proportional reasoning, the thinking. If you're having a hard time coming up with equations, but you're getting the right answers, you're still okay. You just need to be able to write something down that demonstrates to me what you're doing. Then I did this goofy thing to kind of convince myself that I was right. I said if this is 8, that makes this 14. And so that's timesing by 2. See how all the pieces are being times by 2? So my scale factor here is 2. Kind of cool. All right, and then this one was, I went ahead and set them up long. So piece, the 3x over 36, and then 7 over 21. I simplified both of my fractions, so this became x over 12. This became 1 over 3. And so I knew right away that numerator was 4, but I went ahead and cross-multiplied, and there I am. Okay, so there you go. And then you have these two. And these two, you're going to have to use part over whole again. And you can also use the 10 and the 20, the other two sides. So see what you can come up with. And so you can see the answers here. X is 5 and X is 9. I hope you enjoyed it. Have a great day.